Good morning, everyone. I'm Ruochen, and a postgraduate student from School of Cultural Heritage, Northwestern University. The topic of my presentation today is investigating the composition and the application of an ancient adhesive material discovered on the Qin Terracotta Army Statues. Now we shall begin. First of all, I will introduce some background information. As you may know, the Qin Terracotta Army, famous as a World Cultural Heritage, is not only a large military site, but also an extraordinary paradigm of ancient Chinese statues. The statues were discovered in the burial pits of the Emperor Qin Shi Huang's Muslim site. He was the first emperor of ancient China. If I can draw your attention to this slide graph, we could see that the burial pits of the Terracotta Army are a group of large-scale pits outside the tube, of which the number 1 pit is the largest one with more than 6,000 pottery statues of warriors and horses. Here's a picture of number 1 pit. The materials I studied are all from number 1 pit. This is a warrior statue and a horse statue in number 1 pit, which with the archaeological excavations, a special adhesive material has been discovered as blue-gray powder in many statues, such as between the warrior and its footrest, arms and body, neck and hand, sleeve and palm and fingers. And traces of this material also exist in parts of the horses, such as between head and neck, on the surface of the abdomen, especially limbs and hooves. Now, at this point, you may have the same questions as me. What is the composition of this material? How was the material produced, and how did the Qin craftsman use it? These 3 questions are also the main contents of my presentation. Firstly, what is the composition of this material? We used X-ray fluorescence spectrometer and X-ray diffraction spectrometer to analyze the powder. The results of some samples are summarized in this table. The samples are mainly composed of silicon dioxide, aluminum oxide, and ferric oxide with other oxides. The major mineral phases are quartz and albite, which are identical with those of potteries. Now you can see the data at the bottom of the table. There are previous studies on terracotta statues suggesting the components of the adhesive material are the same as the terracotta statues, or the same as the clay that was used for making these statues. So this makes me more curious. How is it produced? Is it clay or is it pottery? Has it been fired? We used the polarizing microscopy to provide evidence for the firing temperature. Dark brown biotite, an important mineral in potteries, is found in samples with cracks being observed, like the 4th picture. According to simulation samples, when potteries are fired to 850 degrees, biotite cracks will appear at the mineral, and the mineral will become darker, like the 3rd picture. In contrast, not much phenomenon was observed for biotite fired below 850 degrees. So we suggest the adhesive material was fired at a high temperature, at least above 850 degrees. Moreover, the samples show another interesting feature, that the debris in the matrix have obvious edges and corners, like the 2nd picture, while the debris in the fired soil, which was selected nearby the sample, are more round, reddish brown, and contain sand-sized inclusions, like the 1st picture. Therefore, we think that artificial grinding may be the only possibility for the formation of the debris in the samples. To verify this possibility, we grind the pottery fragments to for comparison, numerous angular libraries was observed with great similarity to the samples. The third picture, based on all of the evidence above, this adhesive material was probably made of grains ground from potteries. The similar firing temperatures and compositions suggest the adhesive material is related to the statues. For further study of the source of this material, the grain size analysis was performed by Patrick. This figure shows the mineral counting with one major proportion pink in grain size, which is similar to the grain size distribution in potteries. Due to the grading of the material of weather, while water or wind, unimodal grain size distribution always occurs in natural clay. However, when the mineral and clay grains in matrix were counted at the same time, some mineral pinks appear because the clay and a mineral in the original pottery materials experience the same degree of weathering. Their particle size distributions should be the same. When there are two pinks, the other group of particles with completely different particle sizes is likely produced by artificial or grinding. Overall, the adhesive material was ground from potteries. After all of this, since it is just pottery, but how can it play a bonding role? This makes us have to go back to the first question. Does it have other components? We also used gas chromatography with mass spectrometer to determine the organic substances in samples. This is the air current spectrum of a sample. Quantitative analysis was done by integration and calculation of the mass spectrum. The proton contents in all samples are above the limit of detection, suggesting the samples contain proton components, and the quantitative analysis was effective. Amino acid ratios in samples are listed in this table. Hydroxyproline, the character amino acid of animal glue, was detected in all samples and even reached 1.9% in host 1. The average ratio of glassy in all samples is 18.64% and is very close to 20% from Army 1 to Army 6. These glassy ratios are the same as that of the animal glue, indicating the presence of animal glue in all samples. Additionally, the glutamic acid ratios in all samples are high, over 10%, and similar to that of the eggs. The ratios of cerealic acid and aspartic acid are high, which is an exclusive character in eggs. All the results above lead to the conclusion that the organic matter in this adhesive material is a mixture of animal glue and eggs. This is also a common proton binder in ancient China. So it is a mixture of pottery grains and egg with animal glue, but how is it used? A lot of discoveries have suggested it was used to connect some special parts of statues in the Qin Terracotta Army. For example, many statues have been found with stone armor, like the first picture, which suggested that the warriors were made and carved separately and then fired to pottery. To assemble them, this studied special bonding material was used. Otherwise, if the arms and the armor are fired as a whole, there is no space for carving armor. In addition, the material was also used to bond broken parts of the statues. For instance, it was found in the fracture sections, such as the cross-section of horses' limbs and hooves, like the second picture. The other possible intention use is flattening. We found a large area of a horse's abdomen is covered with this material, making this area very flat. Regular impressions were found when the material was scraped off from the surface of the horse's abdomen, and they may be left by the supporting structure during the clay joining. Considering no trace of early fracture in this area, we think that this material was not used as spider here, but to cover the rough surface to form a smoother surface. The material was initially semi-flowing and can be easily applied and polished. Such cases were also found along with obvious traces of fabrics, which was probably another way of flattening. In the beginning, the statue surface with stands was wrapped by fabrics for a preliminary filling, and then the studied material was used to flatten the surface because the rich fibrous structures allow the material and the statue to clung tightly. As you may know, there is a layer of color painting on the surface of statues, so flattening can make the surface smooth enough to show the color. In conclusion, through the study of these three parts, we know that this material is a mixture of pottery, grains, and egg with animal blue binder, and was mainly used for bonding and flattening. We can also get many information from this material. First, the strict arrangement of Qin army. The terracotta warriors were strictly designed according to the Qin army at that time. The warriors placed in different locations in the number one pit represent different identities and functions. So to achieve the integrity of the army and the high quantity of the statues, some statues that were broken in the process of the firing, for example, transportation and arrangement were repaired with this material. Second, we believe that the building a period of number one pit was very urgent. The time pressure drove the workers to repair the broken statues to finish the project rather than abandon them and produce new one. Third, this, as mentioned before, this material has enough bonding strength for having huge statues and is easy to be molded and flattened and resistant to aging and loss. This mixed use of an inorganic filler and organic binder is a crucial reason that it can be used in many ways. Adding inorganic fillers to the organic compound helps solve the problems of using organic compounds alone, including slow solidification and the poor filling ability and difficult to reprocess. This composite material is also widely used in modern society, which combines organic and inorganic components by physical mixing and chemical reaction, etc. This material provides an essential basis for the statues with grand size, large quantity, and exquisite decoration. That's all of my presentation. And at the end, I want to thank the organizing committee for letting me speaking. To be honest, it's my first time to participate in an international conference. So thank you for granting me this opportunity. And I also want to thank my supervisor, Dr. Yang Lu, for helping me do that research. And that's all of my presentation. Thank all of you for listening.